I would like to welcome you to another interesting session. Now, it's a continuation on the topic that we've been considering. This is the second lecture in Introduction to Real Analysis, the second video lecture. So we are still discussing limits. Now, we are talking about the inferior and superior. From the limits that we are discussing, we need to look at the superior and inferior limits. So now, for you to understand this, first of all, we need to look at the definitions. So we look at the definition. So we're saying we want to discuss the limit superior. So we look at the definition, and our definition for this, I don't even know the number for this definition, but I'm assuming that it's one of those under this one. I'll call it 3. It should be 1.3. Yeah, 1.3. So the definition for this is we'll write our xn b, or maybe an be a sequence. So our an be a sequence of real numbers. So the an to be a sequence of real numbers, but the condition is they not need necessarily be bounded. So not necessarily bounded, meaning that they can be bounded or unbounded. Okay. So now we define. So we define the limit as the value of n approaches infinity of the infimum of an to be equal to the sup, which is the supremum of the infimum of an plus 1, and an plus 2, and then this goes on. Then and the limit of the sup to be equal to the infimum, which is the inf of the sup, which is supremum of an plus 1, an plus 2. Okay. So then it goes on like that. So what does this mean? This is as a limit inferior. So we have the limit inferior and limit superior. Of the sequence in this case our sequence an. So now I'll go through the definition. We're saying let an be a sequence of real numbers. This sequence of real numbers need not necessarily be bounded. So we define the limit inferior to be equal to the supremum of the infimum of that sequence, and the limit superior to be the infimum of the supremum of that sequence. As the first one, meaning that this one here is going to be called the limit inferior, and then this one here, this one is going to be the limit superior of the sequence. So in short, we are looking at the limit superior with to be the smallest of the greatest. So if you have a set, that which is the smallest of the big ones, then to be the limit superior. Okay, and then the biggest of the smallest to be the limit inferior. Mind you, this inf means small, this sup means big. So the infimum is basically the biggest of the smallest. The limit superior is basically the smallest of the biggest. So that is what it means. So let an be a sequence of real numbers. So we define the limit inferior of the sequence an to be equal to the sup of the infimum of that sequence, and the limit superior to be equal to the infimum of the sup of that sequence. That's basically the definition. You need to get it just like that. Now, notation. Since we are going to be talking about this, so let's look at the notation. How are we going to be writing this? How is this going to be noted? So the notation that we are going to have will be as follows. Okay, so if we have a sequence like the one that we have, so I'm saying for a sequence an, that is what we have there, then and for each n in natural numbers, then if we have a like this, then this is called the infimum of this an plus 1, an plus 2, like that, up to the last one. Then the limit superior to be the supremum of this same an plus 2 plus 1, sorry, an plus 2, like that. So you see the superior will have the bar on top, the inferior will have the bar at the bottom. So those two notations are going to be used. Okay, so in this case, what does this imply? It implies that if we look at the limit of the sequence an, okay, so the limit of the sequence an, which means the lower limit, is basically equal to the sup of an. They are all at the bottom. So sup means that the smallest of the biggest. Then the lim, now in this case we put the bar on top of n is equal to the infimum of an. So our an, then our bar will be on top. Now that should be understood by everyone. So this is the story that we are going to carry. So this is the story we are going to be discussing from this point onward. But there are some important theorems that we need to consider, which you need to remember all the time. So I'm gonna talk about them next. So let me now discuss them. So now the first one, theorem number 1. So the first theorem in terms of limit inferior and superior is that if the sequence an is any sequence, okay, then the following is true. The infimum of this sequence an is less than or equal to the limit inferior of an, which is less than or equal to the limit superior of my an, then which is less than or equal to the sup. So sup of an. So take note, the inf of an is less than the lower limit of an, which is less than the upper limit of an, which is less than or equal to the sup of an. So this result is true and it should be taken as such. Okay, then the other important result that I wanted to look at is basically, I'll just mention it, is that Okay, let me just look at this theorem 2, very important. I will just give the statement, no need to prove. So I'm saying if we have a sequence an and the okay, if we have a sequence an, then the following results odd. So we are saying the lim of this sequence negative an is equal to negative the lim of on, like that, and the lim of negative an, this is upper, is equal to negative the lim of an. So this is lower. So this is an important result. We have 1 and then we have 2. So these results will be applied in some of the problems or questions that you're going to consider. So I've got 6 problems that I'm going to consider for this lecture. So I hope this will help. So looking at what we have, so let's look at the illustrations. So I will illustrate for you to understand this clearly. So illustration number 1, I'm saying if I have a sequence an which is given by negative 1 to the power n, that is for values of n in this, then what does this mean? So if I look at the value for this, so what is the smallest value of this? So checking, we've been looking at this sequence. We're going to have negative 1, positive 1, negative 1, positive 1. So the limit inferior is going to be equal to negative 1. That is the greatest of the smallest. Okay? Then the limit inferior, it is a bar, is gonna be equal to 1. That is for all values of n in this. That is from this sequence an. Okay. Now in this case, when we are writing, we might even say the limit of an, that is the lower limit of an, is equal to the sub of our an, which is equal to negative 1, or alternatively, I'll write this side, I would say the limit, the upper limit of an is going to be equal to the inf of an. So the greatest of the smallest, this is going to be equal to 1. So take note of that notation. This is for the first example. That is the outcome. Now for the second example, if I give a sequence, so an, and this an is given as 1 plus negative 1 to the power n, that is for all values of n in that, then our an bar, the smallest of this will be basically equal to the inf. Now we need to arrange this. So in short, we are going to have 1 plus negative 1 to the power n. The other one will be 1 plus negative 1 to the power n plus 1. And then it goes on and on. Now if you check, so the smallest of these, so what is gonna be? Now this will be true if the value for our n is odd. So if the value for our n is odd, then it's gonna be negative 1, and this is gonna be negative 1, and the outcome is just gonna be equal to 0. So therefore we are saying our this bar is gonna be equal to 0. Then the other one, the an, with a bar there, this is gonna be equal to the sub of what we have. Same result, 1 plus negative 1 to the power n 1 plus negative 1 to the power n plus 1, and the continuous. Okay, so we have 1 plus that. Now if the n is even, so it means this is going to be 1, it's going to be 1, and if we follow this, it's going to give us 2. Okay, so from here we are going to say that therefore an bar is going to be equal to 2. That's our result. Okay, so now we move on again to look at another example. So in this other example, okay, we have a sequence at 3. We have a sequence an, it is given as n for n in natural numbers. So now what is going to be our an bar? This is going to be equal to n, and we know that our an that is if our an bar is going to be considered, then what shall this give us? Remember, n is a natural number, so in short, if the value of n increases, so we don't need to discuss the lower, the greatest. We all know that the smallest among these is basically 1. So in short, we look at the upper first. So in short, I will begin by saying our n bar is going to be equal to n, meaning that our an bar is going to be equal to this, which is infinite. 1, 2, 3, 4, 5 up to infinite. So the greatest of this is going to be infinite for all n. I hope that is clear. But let me look at the lower part. I think this, when you at this point you can understand this. If I look at the lower part, and this is gonna be equal to the soup of what we have. Okay, so what is the soup of this? The soup of this, the greatest is supposed to be this one, infinite. So we have the soup and the inf to be equal to infinity in this case. Okay, now we look at another example, example 4. I think it's making sense, I'm sure. Now example 4, we are given a situation that is a little bit interesting. So we have an, and this is given as negative 1 to the power n. Now this is over n squared. The value that we are picking are for n in natural numbers. So what do we get? So what do we get here? So the prim of our sequence n is going to be equal to the soup of the infimum of, we're going to have negative 1 over n squared to the power n, and the other one will be negative 1 over n plus 1 squared. This one will be n plus 1. So in short, what are we looking at here? So this is giving us the soup. Okay, so we have got this result, negative 1 to the power n, then n squared, comma, negative 1 to the power n plus 1 over n plus 1 squared. So now from this result, we have these two possibilities. We have negative 1 over n squared. If you look at this one, this is always true. This will always be negative for odd numbers. And then we are going to have again negative 1 over n plus 1 squared. This is true for, so this is true for even numbers. Of course, maybe you're wondering, why am I having this result? So if I put odd here, say I put 3, it's gonna be negative. If I put 3 here, then it's gonna add up to even, but the results will be the same. Both the top numbers will be negatives. Okay, I'll go through again. For even, that is when we take n to be equal to 2. If I take n to be equal to 2, in this case, this is gonna be positive. But if I think so, which means the results will follow according to the behavior of the even number. So if it's 2, 4, for this one, we will have negative. And in this one, when we have even for this one, even means that if we have 2 plus 1, it will become odd. So the moment n is even, this one will behave like this. The moment this one is odd, it will behave like this. So take note. I'm not saying this one cannot be positive, but the statement is what we are looking at. We are looking at the inferior. Okay? The inferior of this here. So the inferior, which means the lower part. So if I put odd number here, this will be negative 1. On this one, if I put even number, so even number plus 1, it will be odd number. So the result will come like that. Now I hope everyone is clear on that one. So now what does this mean? This means that my outcome shall certainly be equal to 0 if n approaches infinity. Okay, so from there, so my outcome will be 0, sorry. So therefore, what is my conclusion? My conclusion is that the limit inferior over an is gonna be equal to 0. So this hopes to apply for limit superior. So the limit superior of an is also gonna be equal to 0. That is, if you check, you put even here, odd there, you swap them, so you have your limit to be equal to the same value. In this case, this value, which is basically 0. I think these are some of the examples, and then you're gonna receive an assignment after we watch this last part of the video, where you need to discuss critically some more examples of limits under inferior and superior. Thank you very much.